You may have heard of photonics. It sounds like electronics, and a lot of applications are indeed the same. Photonics includes all technologies that use light, create light, or modify light. Using light to make electricity, as in photovoltaic solar panels. Creating light using electricity, such as LED lighting technologies. And modifying light, such as in a laser. Nothing goes as fast as the speed of light. If we could travel at the speed of light, we would travel around the Earth more than 7 times in 1 second. This is quite useful in communication. The Internet travels through optical fibers made of glass, thinner than a hair. They transfer the information from one part of the globe to the other. Without optics and fibers, it would be impossible to have email, Google, Facebook, or YouTube. It would be impossible to transfer pictures, music, and video the way we do it today. Products that emit light, such as cinema projectors or miniaturized projectors, television screens, heads-up displays in cars, the display screen of your phone or GPS, a camera that captures light, those are all photonics technologies. Sometimes we cannot see the photonics technologies that use light in action. For example, your CD and DVD player use laser light to read what is on the disc. Photovoltaics is the technology of converting light into electricity, and solar panels can be seen in many places today on rooftops of houses and businesses. Enough energy comes to the Earth in 1 hour that the world uses in 1 year. The applications are not only on buildings and houses, but also on satellites, in remote areas in Africa to power hospitals or provide electricity to villages to allow youngsters to read and study in the evening. A solar panel on a camel could power a fridge, permitting life-saving medicine that needs to remain cool to be transported. Solar cells on a car could be used to power a fan to keep the car cool when in the sun. Solar cells can be used on an electricity-powered drone airplane, and you use a laser to recharge it so they can keep flying in the air. Photonics technologies are also used in the oil and gas industry to gather precious information on temperature, pressure, providing visual images of the drilling operation. Fibers are used to measure oil composition, and in bridges or nuclear reactors to measure the structure of the building for safety purposes. Supermarket barcode scanners, infrared light, X-ray scanners at airports are photonics technologies. But let's review some of the more advanced technologies. In cars. Photonics technologies start off by playing a part in the industrial manufacturing process. High-power lasers are used to cut metal, weld metal, and other metal marking. 3D printing, which you may have heard of. Lasers to cut the textiles, such as the airbag in the car. Cameras for machine vision inspection. Metrology tools for measuring. When looking at the functions of the car, photonics technologies are not just in the internal and external lighting of the car, but sensor technologies and night vision cameras enable the driver to see in the dark. The cameras and the displays are photonic products, and fibers can be used in the car to transmit information. Fibers are lighter and the data transmission rate is higher. In the medical field, microscopes, laser eye surgery, laser for tattoo or hair removal, and cameras in endoscopes are now common photonics applications. But the new potential applications of photonics will be truly revolutionary. Photonics is about capturing light and being able to see, so applications in cancer detection, analysis of cells, bacteria are very important. Light is non-invasive, so the blood sugar level could be analyzed looking through the skin without a needle. In the near future, it may also be possible to restore partial blindness. If you combine a laser with a camera, because photonics technologies can be combined with other key enabling technologies, well, you could recognize a mosquito and shoot it down with a laser. What would this be for? For instance, in Africa, to protect a hospital from mosquitoes to make it a malaria-free area. Photonics and spectroscopy are also used in agriculture. Sensors and cameras on tractors and drones enable the analysis of the land and the crop. What areas need fertilizers? This is called precision agriculture. To analyze how ripe fruits are, you can use photonics technologies, and combined with machine vision equipment, it is used in sorting fruits. Lighting in agriculture is also used for city farming. From security applications to telescopes for space exploration, to night vision goggles, high-resolution imaging cameras for border surveillance, to sensors for chemical detection, photonics is used extensively. Textiles, with displays that illuminate, can be used by firemen so that they are more visible. Light indicators could be built directly into carpets in hotels for directions in case of fire. With sensors that use the properties of light, the police can identify if a driver has been drinking alcohol in a moving car. Lighting is used in shops so that the colors of meat, vegetables and clothes are more attractive. Lighting in schools and offices can be used to improve concentration and make us more efficient. Light is used in museums, and a good example of this is the Sistine Chapel in the Vatican, which uses advanced LED illumination systems especially developed for art. Photonics technologies are used to analyze paintings. They can see paintings and drawings that are hidden behind the painting to see previous versions and sketches, helping to detect fraud and forgery. For instance, ink can be visually inspected on documents to see if someone has been cheating on that check. I'm out of breath, and we could go on and on about the numerous applications. So allow me to conclude by sharing that photonics technologies are amazing, fascinating, and you find them really everywhere. Photonics is a key enabling technology with a very, very bright future. So whether you are looking for a new career, a student that needs to make a choice for your studies, if you're a financial investor or a politician that influences policies, think of photonics, be part of it.